motion chapter. So in this class, we are going to discuss the, you can say, the force chapter, right? So in this chapter, we have we'll be dealing with the force quantity, right? Okay.
Yes, sir.
Chalo, that's great. So now let's discuss. So first of all, let's talk about the frame of reference. The first thing, frame of reference means that whenever, so suppose that there are two persons, right? One is standing at the platform and one is basically sitting in the train. So for the person who is sitting in the train, so they are at rest because they are in the train, they are at rest. But if the person who is standing at the platform, they will see that the Bharti and Sara, who are basically sitting in the train, are basically moving with the same velocity as that of train. Am I clear? Yes.
Yes, sir.
So that's why the frame of reference is a very crucial, you can say, concept in which basically that determines the calculations. So basically for Bharti and Sara, they are basically at rest because they are not moving at all. They are just sitting in a train. But for the Haider, because he's standing at the platform and the car, basically train is moving with some velocity v, so it means that they are having the velocity v as that of the train. Am I clear, everyone?
Yes, sir.
Sure, that's great. Okay, so that's what frame of reference is. So frame of reference means frame of reference consists of an abstract coordinate system and the set of physical reference point that you can say uniquely fix the coordinate system and standardize the measurement. So it is required to calculate the things. It's not in the part of your syllabus, just I have written so that you can understand how does the calculations differ when you change the frame of reference, right? Is this clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Chalo, that's great. Okay. Next thing is that a push or pull. Okay. So a push or pull means that in a simple words, a push or pull is called a force, right?
Yes, sir.
Okay. So basically, force is the thing that we basically see in our day-to-day life, but cannot like not see, basically observe. Because force is a quantity which is not visible, but it can be observed by our actions. Right? Suppose that if you are doing something like pushing, pulling, twisting, stretching, breaking, right? So these are the actions that we perform. In these actions, basically force is applied and force is observed, right, everyone?
Yes.
Yes,
Chalo,
sir.
that's great. Now let's understand the effects of force. So effects of force means basically how do we observe the influence of the force in our day-to-day life. So first of all, a force cannot be seen but can only be observed. As I have told you right now that it cannot be seen, just it can be observed, right? Next thing,
Yes, sir.
a force can move a stationary body. It means that if suppose that something is lying on the floor and it is at rest, so if you basically exert some force on that, so the body will move, right? Next is a force can stop a moving body, right? So basically, suppose that in a very good example, suppose we are playing cricket. You must have seen that when a ball is traveling with a high speed, we basically catch the ball with our hands. So basically, we stop the ball, right? Clear? So that's great. Okay. So next is a force can change the speed and direction of a body. So you must have seen that when a ball is thrown to the batsman hits the ball and the direction of the ball changes. So if ball is traveling in this direction towards you, but when you hit the ball, it will basically travel towards me. The direction will change due to that. Clear, everyone? So because the bat exerts the force on the ball, so that to change the direction as well as the speed. Right, everyone?
Yes, sir.
Heather, Sarah, Arham, Arhan,
Yes, sir.
Bharti, Hanan. Is this clear?
Yes, sir.
Sure, that's great.
Yes, sir.
Okay. Next is a force can change the shape and size of a body. So basically, in the live classes when we had covered this topic, I've basically given you an example of a smiley ball. That I had a smiley ball, so I was pushing. Right, I was applying the force on the smiley ball, so the deformation is produced in that ball. Is this clear to all of you? So that's what the force can do. Okay. Next thing. So in the simple words, if we talk about the force in the basically effects of force, that is, a force is an influence which basically tends to set a moving body, tend to set a stationary body in motion, or it can stop a moving body as well, or which tends to change the speed and direction. I've written twice speed, so it is direction. Okay. Or which tends to change the shape and size of the body. Clear?
Yes,
Yes.
sir.
Sure. Okay, so this is all about the force in the simple manners. Am I clear to all of you?
Yes,
Yes.
sir.
Any doubt so far to anyone?
No.
Sure, that's it. Okay, so that's what force is. Now let's talk about the different types of forces in a very broad manner. Right, so let's understand the balanced force. So basically, force can be divided or classified into two types of forces. First one is balanced forces, another one is unbalanced forces. So now let's talk about the balanced forces. What are balanced forces, first of all? So balanced forces, So balanced forces are those forces which sum up to zero. It means that if all the forces are add up, right, and if this sum or resultant is coming out to be zero, so that is called balanced force. Am I clear to all of you? Bharati, Sara, Heather, Arhan, Arham, and Hanan.
Yes, sir.
Yes.
Yes, sir.
Chalo, that's great. Okay. So as you can see this thing on the screen, that there is an example, right? A heavy box is lying on the floor. So as you can see this thing, we are exerting some force on the left side, but box is not moving. It means that the force of friction is basically cancelling the force of push. Clear? So that's why it is not moving at all. Next thing is that force of gravity is basically applying downwards, because force of weight is a force. So it will be downwards towards the surface. That is the property of gravity, right, everyone?
Yes,
Say
sir.
yes or no, right?
Yes, sir.
And as I've told you that so there would be action and reaction both. We have done this thing in the third law of Newton, that if the box is exerting some force, so the ground will also exert some force on the box. So that force is called as force of reaction. Force of reaction is the force exerted by the ground on the box. Clear, everyone? Bharti,
Yes.
Sara, Heather, Hanan, Arhan, and Arham.
Yes, sir.
Yes, sir.
Chalo, that's great. Okay. So as you can see, this thing that this force of push is cancelled by the force of friction. Force of gravity is cancelled by the force of reaction. That's why the box is completely at rest. Even the forces are acting on it. So those types of forces are called balanced forces. Am I clear to all of you?
Yes, sir.
Yes, sir.
Yes,
Sure.
sir.
That's great. That's great. Okay. So if a number of balanced forces act on a stationary body, it means that if the balanced forces are acting on a body, so the body will remain in its stationary position. It will not move at all. Clear, everyone? That body will not move at all. Due to that, because the forces are getting balanced, they are not like basically they are canceling each other. That's why the body will not move at all. Is this clear to all of you?
Yes, sir.
Sure,
Yes,
that's
sir.
great. Okay. Next is, if a number of balanced forces are acting on a body in uniform motion. Uniform motion means when the body is moving with a constant speed. So that motion is considered as the uniform motion, right, everyone? So that motion is considered as the uniform motion. So if balanced forces are acting on that body, so there will be no acceleration, there will be no change in the speed, only the uniform motion will continue. It means that body will continue to be in its state of uniform motion. Clear, everyone?
Yes,
Yes,
sir.
sir.
Any doubt so far to anyone?
No, sir.
No, sir.
That's great. So next thing is that, so basically balanced forces cannot produce motion in a stationary body, and it cannot stop a moving body, or even it cannot change the speed of a moving body, right? So what the balanced forces can do, they can change the shape of a body. They can change the shape of a body. So suppose that you have a balloon. If you press the balloon from both the sides, what will happen? There will be a deformation in the balloon. Right, everyone?
Yes,
Yes,
sir.
Sure, that's great. Okay. Next is unbalanced forces. Now let's talk about the unbalanced forces. So unbalanced forces will be opposite to the balanced forces. So as you can see this thing that the unbalanced forces are those forces which does not result up to basically which the resultant will not be equals to zero, right? Clear, everyone?
yes, sir.
Sure, that's
Yes,
good.
sir.
Okay. So if the resultant of all the forces acting in a body is not zero, the forces are called unbalanced forces. Clear? So the resultant is not zero. So that's why there would be some net force acting on the body that will basically produce the motion in a body, or that will basically stop the moving body. Right, everyone?
Yes, sir.
Yes, sir.
Yes.
Chalo, that's great. Next is unbalanced forces can move a stationary body, or they can oppose just a second, or they can stop a moving body as well, right? So if they can stop if they can stop a moving body as well as they can also move a stationary body. Clear?
Yes, sir.
Chalo, that's okay. So it means that we have, okay, next thing is that if we want to push up basically a body that is basically resting on the floor, what we need to do is that we need to apply the force of push greater than the magnitude of the frictional force. So as you can see this thing, everyone, I think so. Just a second. Suppose that this body is right here, right? So if we want to move that body on the left hand side, right? So what we need to do is that we need the force of push should be greater than the force of friction. So force of friction is written as with a small f. So it should be greater, right, everyone? So if in that case, net force would be because the total force is not contributing towards the motion. The net force would be F minus F. So it means that whatever the value of force is left, that force is contributing towards the motion of a body or towards basically stopping of a body. Clear?
Yes,
Any
sir.
doubt so far?
No,
Yes,
sir.
Clear? Chalo.
Yes.
Okay. So that's what the unbalanced force is. Okay. So if we want to, okay, one more thing. So as you can see this thing, so when a rubber balloon is held between the hands, is pressed, its shape changes. This happens because the balanced forces are acting on it. So I've told you that suppose that a balloon is basically between my hands. So if I push it, so the deformation will be there. So the forces acting would be balanced forces because only the shape is changing, not there is no motion produced in that. Is this clear to all of you? Is there anyone who is having doubt till now? Hanan, Haider, Arham, Sara, Bharti, and Arhan.
No,
What happened, Bacho? You have switched off the video. Like, what is the reason for switching off the video? Could you please tell me? I continuously urge to basically switch on your video so that we can interact well. If you do not show me your faces, how would I know that you are getting my point, or how would I know that you are attentive in the class? So that will basically not will like basically that will basically will not maintain the decorum of the class. That's how. So please switch on your videos, everyone. If you have internet issue or something like that, so that's acceptable. But if you do not have any issue and it's still you are not switch on opening your videos, so that is a little bit concerning. Because you cannot see the videos of each other. I can only see you. So there is no need to worry about it. Okay. So everything is private in the class itself. I can only see you. Okay. Arhan and Hanan and Arham. What happened, Bachir? So
Sir,
you
did you
should,
call
if
me?
no. Yes, Hanan, I had called you. Basically, why did you switch off the video?
But my camera is on.
Oh, your video is not visible to me, Hanan.
Mm, Let me join again.
Yeah. Arhan, what happened? Arhan, are you there in the class? I think so. Yes. So it's a request to all of you. Whenever you are joining the class, so you have to give your 1 hour completely to the class. Just dedicate yourself for the 1 hour itself. It's not for the physics. It would be like it's for all the classes, right? So you are here for the learning because you are giving your extra time here from the school, apart from school. That is a very hectic task, right? You are giving your resources, you are giving your efforts, you are giving your time. So, okay, so please be attentive in the class. Okay, please interact with me. Right, everyone? I hope you got my point, everyone.
Yes, sir.
Okay. Arhan, are you there? Still. Chalo, check. Okay, next thing. Now let's talk just a second. Let me share my screen again. Everyone, can I take a 1 minute pause? It's actually Azan right now. Just 1 minute pause. Okay, thank you. Okay, everyone. Thanks so much for waiting. Thanks so much. Okay, so let's start. Okay. So basically, in the in the first law, in the first law of motion, basically we have two things. First one is inertia, right? So so basically, the first law is completely based on the inertia concept, right? So basically, what inertia is? So inertia is a property of a body uh, due to which it resists a change in its state of rest or of uniform motion. If suppose that your body is in motion. So inertia, what inertia will do is that inertia will oppose the change in state. Suppose that, so there could be only two possibilities, so basically the first possibility could be that the object is moving. So the change in position would be motion to rest. Or if the object is at rest, so the possibility would be rest to motion. Okay, only two possibilities are there, yes or no, everyone? Is there any other possibility apart from it? No, no.
No, sir.
So yeah, so
No.
very good. It means that the inertia will oppose the motion of the change of state. Basically, oppose the change of state. So the inertia will say that, suppose I'm sitting right now. If somebody wants to basically, if someone is basically changing my inertia or my state, so my body will say, no, no, I just don't want to change the state of my body. I just want it to be in rest. If I'm running, so my body will say, I just want it to keep running, because inertia is the thing that will oppose the change in state. Clear, everyone? Just a second.
Yes, sir.
Okay, thank you. Chicken. So next thing is that, okay, so heavier. So now let's understand what are the things that can affect the inertia. The only thing that can affect the inertia is mass. It means that heavier objects will have more inertia than lighter objects. Clear? So inertia is determined by the mass itself only. Clear, everyone?
Yes, sir.
Yeah, that's great. And mass is a measure of the inertia of body. It means that heavier the mass, more will be the inertia. You must have seen that. Is it like it's almost impossible by a single person to move a bus, just to push the bus and the bus will move. Is it possible? No, not. But it can be it is possible that a single person can move or displace the car single-handedly, or even the two-handed force. It is possible because car is not that much heavy. If we basically exert the same amount of force, that the required amount of force, car can be displaced, right? So from this from this example you can see this thing, that car is not that much heavy as compared to bus. So that's why the inertia, basically the resistance offered by the bus would be more as compared to force, because of the higher mass. Clear, everyone?
Yes, sir.
Next is
Yes.
a boy at rest. A body at rest will remain at rest. So this is the first law of motion statement. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed. So both of the conditions are basically included in it, unless an external force to change its state or of rest or of motion is applied. Okay? Is applied. Last word is missing. Is applied. Right? So unless the external force is not applied on the body will not change its state. Clear, everyone? So this is the first law of motion statement. And I've checked the copies of physics of so many students, and I've seen that there is a lack of explanation. You do not explain it properly. I'm not able to remember the name of the students, but I've seen this thing very frequently. So it's a humble request to all of you. Please go through the notes. These notes are sufficient for the school exams and everything, any kind of exam. Okay, so if you do not revise the notes, so your marks will not that much improve. So it's very, very important to revise the notes. Clear, everyone? Heather, Bharti, Arhan, Arham, Sarah, and Hanan.
Yes, sir.
Yes, sir.
Check. Yeah,
Yes.
check. Next is, okay, now let's understand that what will happen if you basically, what are the consequences of the first law of motion? First is basically, when a hanging carpet is beaten with a stick, the dust particle out of its coming out of it due to the change of its state. It means that when the carpet is beaten with the sticks, the carpet will move. It will move. So, but the dust particle wants to be at rest. So that's why they will get separate from the carpet. Am I clear to all of you?
Yes, sir.
Chalo, that's great.
Yes, sir.
Yeah, very good. Now, next thing is when a car or bus starts suddenly, the passengers fall backward due to the change of state. So this is happens due to the change in state, because you were like when the bus was at rest or car was at rest, you are also at rest, but suddenly the bus or car accelerates, due to which you will fall a backward fall. Okay, so that's why. So this happens due to the change in state, and the body of the inertia will oppose it. Is this clear to all of you? Please do let me know.
Yes, sir.
Sure,
Yes, sir.
that's great. That's great. How many
Yes.
of you have traveled in metro? Like like every city has metro right now, like Hyderabad and all the Delhi as well. No one did. Okay, Arhan did. Okay, basically Arhan lives in Delhi, so and the metro station is very near to us. Okay. Okay. Apart from Arhan, no one did. Okay, Arham also. Arham, where do you live?
I live in Saudi, but I have traveled in metro in another
Uh,
country.
Acha, okay, I think so. That would be tram.
No, it was metro.
It was
in
metro. Which country?
Yeah, Turkey.
Acha, Turkey. Chalo, check. Okay, that's great. So, so when basically when you will travel in a metro, na, so if you're standing in a metro, so metro accelerates at a very greater rate. The acceleration of metro is very high, right? So you will, if you do not have any kind of support, you will fall backward, because it's feel like that someone is pushing to you in the backwards direction. So that's why. So you can like you can feel observe these things in the real life, right? Next thing is that when a moving bus or car suddenly stops. So you suppose that you are sitting in a bus, right? So if suddenly stops, so you will basically go in the forward direction due to the forward. So this is called forward jerk, a sudden jerk in the forward direction due to the change in state. So that's why seat belt are mandatory in every car and vehicles, just to basically avoid any collision of the any body organ to the car dashboard or something like that. Clear? And next thing is that when a car or bus suddenly takes a turns or corner around a sharp corner, so we find that we fall in the sideways. Suppose that bus is going like this, we always go in the rightward direction. Bus is basically turning in the left direction, we always go in the left direction due to the basically the inertia. Clear, everyone? So Newton laws of motion gives us the definition of force. So this is the force that we'll study in the second law of motion. A force is a quantity which changes or tends to change the state of rest or of uniform motion. Clear, everyone?
Yes, sir.
Yes, sir.
Chalo, that's great. Okay.
Yes.
Next is force is a vector quantity. We do know this thing very well, that force is a vector quantity. So, okay. Chalo, that's great. Okay, I'm basically activated the thumbs up. So it will be thumbs up all the class around. Like, okay, chalo, theek hai. So Aram, where are you from basically? From India?
UP.
UP.
Yes.
Which part of UP?
Bareilly.
अच्छा बरेली ठीक है चलो ठीक okay. Now next thing, okay, so this is about the first law of motion. So first law of motion is very simple. Only conceptual types of questions are there. So the question that we have discussed, like why do we fall forward, why do we fall backwards, and why do we fall sideways when a bus or car takes a side turn, sharp turn, and why the dust particle comes out of a basically carpet if we beat it with a stick. Okay, and these are the things that you should understand. Okay, so these are the applications of first law of motion, and these are the conceptual questions that could be there, right? The statement could be changed, that suppose that they can ask like in any other manner, but the concept would remain same, right everyone?
Yes.
So now next thing that we are going to discuss is the momentum. So is the momentum is a quantity that is defined as the product of its mass and velocity. It means that when a moving body is there, so the momentum can be defined from the product of the mass and the velocity of its body, of that body basically. Clear everyone?
Yes, sir.
Yes, sir.
Okay, Arham? Yeah, take your time. No need to. Okay, next is the quantity of motion in a body depends on the mass and velocity of a body. It means that how much body, how much the motion is possessed by that body is considered by the momentum quantity. So, if suppose that two bodies are moving, like suppose, okay, so the momentum will basically define which body have the more quantity of motion, right, everyone? So you must have seen that when suppose that, let's take an example. Suppose that a bus is moving with a very small velocity, like 10 meter per second, and a car is moving with suppose that 40 meter per second. So basically, you can see this thing that bus will impact more, even it is moving with a slower speed, because the mass of the bus is very large, right? Greater in magnitude. Okay, so basically momentum depends on both mass and velocity. As you can see this thing from the formula that P is equals to mv. So momentum is also directly proportional to the mass as well as the velocity. So both the things are responsible for the effect, okay, on the body, right? So, and if we take an example, so suppose that you must have heard like so many times on the news, like there is an accident, like, okay, road, like I'm not able to recall that proper name. Rage road or some rage driving or something like that. I'm not able to remember. In which basically, the car is driving with a very, like a car is traveling or riding with a very high speed, right? Around 100 kilometer per second, 200 kilometer per second. When they basically collide with any kind of obstacle, the accident is very worse, right? So that's why. So momentum at that time, the momentum of that car would be very high due to this high speed, right? But suppose that if a car is moving with a very low speed, and if basically there is an accident happened with that car, so the injuries could be minor, but that won't be severe, right, everyone? So that's why momentum will determine how much impact will be there on the body. Okay, how much motion is there in the body. So a body at rest, its velocity is zero, hence the momentum will also be zero. Is this clear to all of you?
Yes, sir.
चलो,
Yes, sir.
great, ठीक है. Next thing, momentum is a vector quantity. So momentum will have, like, momentum could be zero, momentum could be negative, momentum could be positive, and the negative and positive sign will tell you the direction. We've discussed this thing in the motion chapter, that vector quantity, this negative sign associated with the vector quantity will tell you the direction. If the motion is in opposite direction, so there will be a negative sign, right? And one more thing, and when like in the exam revision test, like most of the students have not mentioned the negative sign along with the force. There were some questions based on the force in which the negative sign should be, even the acceleration is a vector quantity, so negative acceleration could happen, like, is it like negative acceleration is also possible? So please mention this sign along with the quantity if the quantity is vector quantity. And if the sign is negative, so please specifically mention it. Do not write just 4 meter per second square. If the negative sign is there, so you have to mention the negative sign, else the answer would be wrong. Clear, everyone?
Yes, sir.
So that's why
Yes,
it's
sir.
okay. Please mention the negative sign if the quantity is vector and even this answer is coming out to be in negative. Okay, so this is all about the momentum. Next thing is that these are the basic questions based on the momentum. So what is the momentum of a man of 75 kg with it, like if he is moving with a velocity of 2 meter per second? 75 and 2. So if you multiply them, you will get the 150 kg meter per second momentum. So kg meter per second means that when you multiply the mass, which is kg, velocity is meter per second. So the SI unit comes out to be kg meter per second. Is this clear to all of you? Please do let me know, everyone.
Yes, sir.
Any doubts
Yes,
so
sir.
far to anyone?
No, sir.
चलो that's great. Okay, ठीक है. Next thing is that a body of mass 25 kg has a momentum of 125 kg meter per second. We need to calculate the velocity of the body, right? So as you can see, this thing, two things are given to you. Acha, one more thing I've seen in the exams while checking the answer sheet, that like most of the students do not mention the units. In physics, units are the most important thing. If you do not mention the units, how is it possible to determine whether which quantity is it? Is it possible to determine? No, na? So that's why please mention the units while you are writing something in the physics. Meter per second square, Newton, kg meter per second. Okay. Clear everyone?
Yes, sir.
Yes, sir.
ठीक है. And time is given in second. So time would be in second hours. ठीक है. Okay, just a second. It's no. Okay, next question is basically that is written in front of you, that calculate the momentum of a following: an elephant of mass 2000 kg at moving at a speed of 5 meter per second. So right, let's calculate the momentum. So 2000 kgs. So if you multiply them, so it would be 10,000 kgs. Clear everyone? And bullet of mass 0.002 kgs moving at a speed of 400 meter per second. So if you multiply it, the momentum is 8 kg meter per second. So you can see this thing, the elephant is not moving with a very high speed, but still the momentum is very, very large as compared to the bullet that is traveling with a very high speed, that is 400 kilometer per 400 meter per second. If you convert it, it would be somewhere 1000 kilometer per second per hour. Okay. Please do let me know, everyone, is this clear to you or not?
Yes, sir.
Yes, sir.
Any doubt so far to
Yes,
anyone?
sir.
So from now on, so how many of you have done the revision of motion chapter completely, apart from the revision test, on your own? Is there anyone who did the complete revision of motion chapter? Achha, how many of you solved the NCRT examples and exercise? Okay, Arhan. Okay, Hanan. Okay, Bharti. Okay, Sara. What about Heather? Arham? You do not solve, Heather? Solve it. Achha, theek hai. It's very, very important. Like we do every type of question in the class itself. We do the NCRT question, we do the extra questions apart from NCRT. But it is your responsibility that you should solve the NCRT after the notes. Okay. Because you once you get the concept, you have to solve it. Okay, because the questions comes from NCRT, even from PYQ. So there are a variety of questions that would be there, but the concept would be same, and the concept will be brushed up by solving the numericals as much as you can. Clear everyone? Achha, how
Yes,
many
sir.
of you solve the basically question numericals done in the notes till now? You have done like almost around 70 to 80, like no, not 70, 80, at least 50 questions in the class itself, 50 to 60 questions. How many of you have solved all the questions from the notes? From your own, after like apart from the class, so you must have revised, so you will be practicing something. So how many of you solved the questions from the notes? Okay, Hanan did. Bharti, Arhan, Heather, and Sarah. Acha, Bharti did. Arhan, Heather, and Sarah. नहीं किया? अच्छा, Arhan did. ठीक है. Honestly बताओ देखो. I'm not punishing you or something like that. Just tell me honestly. ठीक है. So please and please do the revision as well, everyone, from the notes. The numericals from the notes are basically the basic as well as the complex numericals that will help you to understand the concept in a better manner. Right? How many of you
Yes, sir.
are solving the assignments that I have given you? Hanan did. Heather did. Bharti, Sara, Rahan. Okay, Rahan did. Yes, Bharti, you didn't solve the assignment?
So not all of them.
Not all of them. Okay. Okay, so it's from like as you have access to the assignment till now. So what you can do is that to practice more and more, you can solve the assignments. Okay. So like the assignment that you have already solved, you can practice it. And the assignment that you haven't solved yet, you can also practice them and upload it on the app so that I can check them and let you like I will basically inform you in which part you are lagging or which part is missing or something like that. Clear everyone?
Yes, sir.
Right?
Yes,
So
sir.
how many of you will do this thing? How okay, Bharti will do, Hanan will do, Sarah, Arhan, and Heather. Okay, Arhan will do, and Sarah will do chicken. So I hope that you will obey my request. And okay, so it's okay. So I don't think so there, but okay. In the next class, we will complete this revision of the force because only second law of motion is there and the conservation, third law of motion. So it will take around 1.5 class to complete this thing. Okay. So after that, let's see what we'll do. We will be solving some more numericals from the NCERT exemplar or somewhere else. Okay. But you have to revise and revise. The only key to perform well is the revision and this practicing the numericals. Clear, everyone?
Yes, sir.
Any doubts so far till now? Arham?
Yes, sir.
Yes, Arham. I was just saying that you have to solve the assignments that I have given so far. Okay, so all the assignments are on the app. So the assignments that you have solved, so that is well and good. You can practice them, and the assignment that you have not solved yet, you can practice it and upload it on the app so that I can check them. Okay?
Yes, sir.
Will you do that?
Yes, inshallah.
Check. Okay. So yes, Sarah, tell me.
Sir, I wanted to know the general relation between inertia and mass.
Inertia and mass. Inertia is directly proportional to the mass. More the mass, more will be the inertia.
Okay, sir.
Suppose that, like in a simple word, suppose that there is a very fatty guy, right? 100 kg or 200 kg, something like that. Is it not possible to move that guy? Like, okay, but if a person is basically 50 kg, 60 kg, so it could be displaced. So